Hi, and welcome to our lesson on finding zeros of polynomial functions. Really, this is a wrap, folks. You already have many tricks for finding the roots or the zeros of polynomials. Today we're going to give you just a couple more little tricks, and then we'll have really a nice toolkit for solving polynomial functions. We'll begin with the rational root theorem. This looks really nasty, but it's really not as bad as it looks. F of x here, this is by definition what a polynomial function looks like. That is, it's a function where exponents are integers and positive, coefficients are real numbers. This particular theorem, though, says, supposing that those coefficients are integers as well, and there's some rational number that is a root of the function. A rational number can be written in fraction form. What this says is that the top of the fraction p is a factor of the constant term, and the bottom of the fraction, the denominator, is some factor of the leading coefficient. So in layman's terms, what this is saying is, if there are going to be rational roots, they'll be in the form of and here it comes, factors of the constant divided by factors of the leading coefficient. Okay, take a second, coefficient. Take a second, drink that in, okay? If there are going to be rational roots, they will be in the form of a fraction where the numerator is some factor of the constant term and the bottom is some factor of the leading coefficient. Now I want to have us just look at this and put it into practice once or twice. It doesn't give you the zeros, only the possible numbers, rational numbers that could be zeros. So this question doesn't say solve, it says find the possible rational zeros of this function f of x, where x to the third plus 2x squared minus 5x minus 6. The rational root theorem says we have got to list all the fractions that are like this, factors of -6 divided by factors of 1 in this case. That's the constant, -6, leading coefficient assumed to be 1. So if you think about this, having the 1 on the bottom makes this a little bit easier. Factors of -6, well, it could be positive or -1, could be positive or -2, could be positive or -3, could be positive or -6. All of those have to be divided by the factors of 1, which are always positive or -1. So really, I'm going to write these, but they're not necessary down here, because if all we're doing is putting it over 1, it doesn't change anything. So our possible rational number roots for this particular function would come from the set plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now I want to see if you've got that. We're going to ask you to do the same thing with this function. The constant term is -20. The leading coefficient is 2. So we need factors of -20 divided by factors of 2. Alright, go to it. Okay, here's my list. The factors of 2 are only 1 and 2. So what I did was, first of all, list all of the factors of -20 over 1. So I put a plus and minus in front of this whole bracket because all of these have to be plus or minus. 1 is a factor of 20, 2 is a factor, etc. Then I went back through and said, okay, all of them could also be divided by 2. Oh, I see, I forgot something. I did not write in here 1/2, because yeah, that's a possible fraction that could come out of here, dividing by 2. See, all of them are whole numbers here, divide by 1. When you start dividing by 2, this one could be affected. See, 2 divided by 2 is already 1, that's already listed. 5 could be affected. 5 divided by 2 is not any one of these numbers, and then everything else is good. So if there were going to be a possible rational 0 or zeros for this function, they have to come from this list of numbers. Okay, that's pretty good. To determine whether any of those possibilities is actually a 0, you have to divide by it. Okay? So that's why synthetic division will be our friend, because it's quick. Okay, synthetic division. Yay! Once we know what one of the zeros in a third degree polynomial, a cubic, is, then you can use the quadratic formula on it's called the depressed polynomial, because it's so sad. Depressed polynomial, which is found by, and again, that's found by using synthetic division. All right, now we really are going to try it. We are to find all the zeros of this function, x to the third plus x squared minus 5x minus 2. So a good starting place would be to list possible rational zeros. So here come the possibilities. Leading coefficient is 1. Constant is 2. So really it's just factors of 2, you guys. Our possibilities for rational roots would be positive and negative 1, positive and negative 2. Next we gotta just pick a root and try it. This is a trial and error process. I'm gonna pick negative 1 to start with. I'm going to see if that goes into this polynomial. 1, 1, negative 5, and negative 2. And why don't you pause the tape, do that synthetic division, let's see if we found a root. Negative 1 did not work. What about positive 1? I'm going to do my work up here. So coefficients are 1, 1, negative 5, negative 2, and this time I'm trying positive 1. 2, 2, negative 3. Oh, that's not working either. Well, I'm lowering the probabilities, I guess. How about 2? 1, 1, negative 5, negative 2. Drop, multiply, add, multiply, add. Ooh, I like it. There's our 0 right there. Okay, so we know for sure that one of our roots is 2. Now we have to find the other 2 by either factoring or quadratic formula with the depressed polynomial, which is, remember you were to a third power here, so this is the coefficient of a second power term. X squared plus 3x plus 1 is our depressed polynomial. Folks, that does not factor. We're going to have to quadratic formula here. Yeah, because you can't multiply to make 1 and add to make 3. That's not possible. So our A is 1, B is 3, C is 1, and let's see. X will be opposite of B, negative 3 over twice A, plus or minus b squared, that's 9, minus 4 times a times c, those are both 1, all over twice a. So it looks like we're coming up with x will be negative 3/2 plus or minus the square root of 5, which cannot be simplified, over 2. And folks, that does give us our 3 roots, because we've got -3/2 plus this and -3/2 minus it. So I'm going to just add those to this list, -3/2 plus or minus the square root of 5 over 2. And there are 3 roots. I will tell you, I'm kind of glad that it turned out this way, that I picked 2 bogus things to divide by before I picked the real one, because I just want to remind you, we won't always know for sure. You may have to try more than once, maybe more than twice, to find the first divisor, but once you do, oh, it's such a wonderful feeling. All right, that's all I have for you today. Want you to get out there, try the U-Try, and we'll talk about this more in class tomorrow.